Welcome to Getting to Know Google SecOps. I'm John Stoner, and today we're going to take a look at a time function that takes a string that is formatted like a time and convert it to a timestamp, which can then be used with additional time functions. Mind-blowing, I realize, but don't worry. We'll walk through a couple different ways that we can use the timestamp as Unix seconds function today. And like the other functions we've been discussing, it can be used as you build searches and rules in Google SecOps. On occasion, we might find ourselves with a date-time value in a string field. It doesn't matter how it got there, but it's there and we want to use it just like we would any other timestamp. This can be challenging because it's a string, and at this point, how can we calculate a time difference between two strings? Luckily, the timestamp as Unix seconds can help us. This function does expect the string format of the date to be in the form year, month, day, hour, minute, second, or for those who watched our previous video on timestamp.getTimestamp, the format element of %f%t. However, once our string is in that format, we can use the other function with the single argument of the field or variable and output an epoch time value that can then be used with other functions. Due to the value moving from a string to a timestamp, there may be a number of other nested functions used to accommodate this, including strings concat or string substring, not to mention other timestamp functions if performing a comparison. But we have videos on these if you need a refresher on any of this. Let's put this into practice. We're going to start by building a simple search for GCP firewall events. In our output, we have a series of parsed and extracted fields from the raw data. My instance doesn't happen to have a bunch of dates in string fields, so these extracted fields serve as an excellent surrogate because the extracted field is a string but contains a time value. In case you don't believe me, let's do a quick test. A common time question is, what is the difference in time between when my event occurred and when the event was received? To find the answer, I could add an outcome section to my search and calculate the date difference by subtracting the value from the extracted received time field from the event time. When I add my statement, I get a compilation error because the search is expecting an integer or float value instead of the extracted field, which is a string. Let's try something different. I'm going to go ahead and paste an example of the extracted field into my search and comment it out. You'll see why in a minute. And I'm going to go ahead and add a few lines to my outcome section. We're going to use our timestamp as Unix second function to convert our date that is a string, and we're going to go ahead and display the event time, and then we're going to go ahead and calculate the difference between these two values. Notice now that my search compiles. I'm feeling pretty good until I see the results. It appears the converted Unix timestamp is -1 for all the rows. The reason for that is the conversion from string to epoch is specific in the format. Notice in the example value that I pasted in as a comment above. Now, having done some testing, it isn't so explicit that it can't handle the T that separates the date and the time, as well as the decimals below the second level. But clearly in this case, we can't just use our function and call it a day. Let's take a look at a few different ways we could prepare our string to work with our function. This is where string functions like strings concat and string substring come into play. The format has to be year, month, day, hour, minutes, seconds. I'm going to show you 3 ways that this worked for me. The first method is working across the entire string and including the T using the stubstring function and collecting the first 19 characters of the string. The second example is grabbing the first 10 characters for the date, concatenating a space, and then taking the 12 characters starting in position 12 of the string to collect the time, including the 3 decimals under a second. The final example is being a bit more strict and just collecting the date and time and leaving out the T and the subseconds. When we test our search, We can see that all three of these are valid approaches, and the result is a nice epoch value that can be used with the event time to generate a time difference in seconds for the firewall logs. Once a string is converted to a timestamp, we can do more with it, both in a rule or a search, but hopefully this highlights how we can convert a date in a string field to an epoch value. The timestamp as Unix seconds function converts a date value in a string to a timestamp that can be used in time operations and is very simple to use. You just supply the field or variable the value resides in. That having been said, it does require a format of year, month, date, hour, minute, second. And because of that, variables like strings concat and string substring may need to be used to format the string properly before converting it. The good news is that once the conversion occurs, these values are treated like any other date and timestamp function for formatting or other logic that can be applied to them as needed. If you want to learn more about Google SecOps, check out my blog series called New to Google SecOps for more handy tips. We have a number of community URL detections at our GitHub site and are continually adding more. And don't forget to engage the security community at secopscommunity.com.